Hello again. It's me. Yeah. Same old guy. Sorry about that. Um, anyhow, let's get started on module 5. And we're going to talk about hazard communication. Now, you may have heard of hazard communication 100 times before, just in my classes, taking any of them. But that's okay. And I'll tell you why. Because hazard communication is a very misunderstood subject and gets a lot of written OSHA citations because it's not being followed. And most people that aren't in the safety business don't really understand it. So anyhow, so we're going to talk about the basic resources available for responders too here, define methods for identifying hazard materials, discuss hazard communication, and safety data sheets. Identify dot hazard labels and placards, discuss hazard materials information system, HMIS, interpret and use the emergency response guidebook, and just do some terminology definitions. Fundamentals of Haz Mat. On an incident or emergency response, it's the emergency responder's job to identify, categorize, and verify the hazards. You got to know what the hazards are. Numerous resources are utilized to make the task easier and quicker. Many regulations are in place to do the same. HazCom includes safety data sheets, dot hazard labels, dot placard labels, dot hazard placards, HMIS, NFPA labels, employee awareness and training. There's a lot of things involved here in this. Safety data sheets, or SDSs, are primary sources of information on chemicals and materials. They contain specific information to help responders and workers identify hazards and risks. They also contain a lot of information that's kind of like CYA for the company, and they will just say anything there. You'll notice every time it says disposal, it always says disposal in accordance with state, federal, and local regulations. Well, that really doesn't tell you anything, does it? So, SDSs are developed by the chemical manufacturer. They are shipped with the chemical when purchased. They are periodically updated as chemical information changes. They have the following requirements. They must be printed in English. They can be in other languages too, but they have to be printed in English. Must have the manufacturer contact information. You have to be able to call them. Every space must be completed. In other words, none of the 16 areas can be blank. You can put in there information, but you just can't leave it blank. You have to include the preparation date and the last known revision date. Sections 1 through 8 contain general information about the chemical, identifications, hazards, composition, safe handling practices, and emergency control measures, such as firefighting. This information should be helpful to those that need to get the information quickly. Sections 9 through 11 and 16 contain other technical and scientific information, such as physical and chemical properties, stability and reactivity information, toxicological information, exposure control information, and other information, including the date of preparation or last revision. The SDS must also state that no applicable information was found when the preparer does not find relevant information for any other required elements. So identification of the chemical is number 1. Number 2 is hazard identification. That will include a signal word and a hazard statement. 3 is composition information on the ingredients. 4 is first aid measures. 5 is firefighting measures like suitable firefighting equipment and special hazards. 6, accidental release measures, personal precautions and emergency procedures. 7, handling and storage. 8, exposure controls and personal protection. 9, physical and chemical properties. 10 is stability and reactivity. 11 is toxicological information. And 12, ecological information. 13, disposal considerations. 14, transport information. And 14, regulatory information are non-mandatory, and they won't be enforced by OSHA because they are in there to make this compliant with other countries, to make it all. So that's why it's called the globally harmonized system. And then 16, other information, and that's where the date prepared and date of last known revision has to be. So SDSs are your best and most accurate source of information on the chemical. Scientific data is used to get this information, but what if one is not available? I mean, not that the company doesn't have one, but on the site, on the scene, you don't have an SDS, which probably going to happen a lot of times. So other sources of identification are helpful. NFPA 704, another labeling and placarding system that can identify materials hazard, is the National Fire Protection Agency, NFPA 704 system. This is used on individual containers rather than on shipping containers. NFPA 704 system identifies multiple hazards of a material. There are 4 categories: health, fire, reactivity, and a specific hazard. And that's what they are. The red is health or fire, fire hazard. And the numbers all in those 3, except for the white one. Let's talk about the 3 color one. The higher the number, the worse it is, or the more hazardous it is. 4 is very flammable. 3 is readily ignitable. 2 is ignited with heat. 1 is combustible, and 0 will not burn. I hardly ever see a 0 in any of these, though. And on the health hazard, 4 is deadly. 3 is extreme danger. 2 is hazardous. 1 slightly hazard, and 0 is normal materials. Reactivity hazard, 4 may detonate. 3 is shock and heat may detonate. Violent chemical changes, 3. Unstable. If heated is 1, stable 0. Now, specific hazard, OXY is an oxidizer. Acid is acid. ALK is alkali. COR is corrosive. And the W with a line means line through it means use no water. In other words, you put water on that sucker, there's going to be problems. Now, HMIS, the Hazard Communication Information System, is very similar to the NFPA 704 system, but allows for additional hazard and protection information. Again, it uses the 4 pretty much the same way, the numbers there, and blue is health, red's fire, reactivity, and then PPE is in the white. So it's similar. And the health number 4 is deadly. Again, extreme danger, dangerous, slight hazard, no hazard. So 4 says even the slightest exposure to this substance would be life-threatening. Only specialized protective clothing for these materials should be worn. So if you don't know what you're doing, well, you don't want to mess with that. That's for sure. Flammability, flash point below 73 degrees and boiling point below 100 degrees. This subject is very flammable, volatile, or explosive, depending on its state. Extreme caution should be used in handling or storing these materials. So, and that goes down from there. Reactivity may detonate. Substances that are readily capable of detonation or explosion at normal temperatures and pressures. Evacuate area if exposed to heat or fire. And that goes down to explosive, unstable, normally stable, and stable. And then personal protective equipment, A is safety glasses, B, safety glasses and gloves, C, safety glasses, gloves, and apron, D, face shield, gloves, and apron, E, safety glasses, gloves, and dust respirator, F, safety glasses, gloves, apron, and dust respirator, G, safety glasses, gloves, and vapor respirator. And you can go down there, H, I, J, K, airline hood or mask, and X, as supervisor or safety specialist for handling instructions. So as an X on there, that means we're not sure. Go ask somebody that knows more about this than we do. Okay, this is hazard communication labeling, target organ information. And I'm going to need some help, right? Just to read this little stuff. So a neurotoxin affects the nervous system. Agents may produce their primary toxic effects on the nervous system, the neurotoxin. Cutaneous hazard, chemicals which affect the dermal layer of the body, which we call skin. Lungs, agents that damage the lungs, chemicals which irritate or damage pulmonary tissue. Reproductive toxins, chemicals that affect the reproductive capabilities, including mutations and effect on fetuses. Eyes, chemicals which directly affect the eye or visual capacity. Blood, agents which act on the blood or hematopoietic system. Decrease hemoglobin function, deprive the body tissue of oxygen. You don't want that to happen. Hepatotoxin, chemicals which produce liver damage. Kidneys, nephrotoxins, chemicals that produce kidney damage. So you have acute effect, that occurs rapidly as a result of short-term exposure, and chronic effects occurs as a result of long-term exposure. Safety data sheets, NFP 704 labels, and HMIS labels, these all help identify hazards of the chemicals in the workplace. And that's where this chapter stops, 75. As you can see, the sun is going down there. So, of course, where I sit here in my house, I'm facing the north. So that sun is going down behind me. It's going down in the south. The sun is setting in the south. There's a problem. So just you've been warned. So, all right, be safe, everybody.